And I just want to let everyone know that we are launching our very first Western time zone data engineering bootcamp cohort at the end of the month. So if you're interested in learning more about data engineering, I think tonight's topic will be sort of a, it will give you a pretty good idea how we approach teaching. But what we're covering, tonight or in the past few days is a very small part of, the bootcamp. Yeah, if you'd like to learn more, you know who to talk to. Our Eastern cohort time, will start in February next year. All right, that's my quick introduction, and I hope everyone enjoyed the session. Stan, over to you. You can do a quick self-introduction and look forward to your lecture.
Good evening, everyone. Thank you for joining today's session. Can you guys see screen and can you guys hear me?
Yep.
Okay, great. So let me introduce myself first before we start. So my name is Stan. I'm currently working as a data engineer in Telus. Anyone from Canada probably know this name. If you're not from Canada, Telus is one of the biggest telcos in Canada. I'm working in cybersecurity division. So our team is responsible to collecting data from thousands different devices. We're collecting these logs. And then using the ETL pipelines, transform the data, store the data in a lake house, and then making available to a data analyst to analyze the data and derive the insights and to detect any threats and any intrusions within the network. So yeah, handling quite sensitive data. We're ingesting about 12 terabyte data a day using mostly streaming pipelines. So yeah, it's a pretty exciting field to work. And prior to that, I basically changed the my career before, right? I have no data science or software engineering background, but I have an engineering background. So I kind of decided to change to data engineering. Actually, I graduated from data engineering course, and I'm currently working as a TA and an instructor for data engineering bootcamp. So let's start with Lambdas, with serverless solutions that AWS provide, and let's just talk about what actually serverless services are. And then I will try to first part of this today class will be mostly theoretical. So we'll talk about Lambda a lot, about different serverless services that AWS offers, and then we'll talk about how Lambda works, and then I will try to show you a demo of Lambda, show you the UI, and how to submit your Lambda, how to troubleshoot your Lambda, test your Lambda, and so on. Please feel free ask questions if you have. So yeah, let's make it kind of a little bit interactive. Yeah. So let's start with evolution of cloud services. I'm pretty sure you guys probably familiar with or heard about AWS. Probably most of you have AWS account already, and you probably try to deploy some AWS services. And some of the most famous AWS services is EC2. And EC2 is IaaS, meaning is infrastructure as a service, meaning so you kind of renting hardware that you can, like use for your purposes. So you're basically renting a VM machine. You can install a different operating system on it, and then you can do whatever you want with it. For example, you can install a website, like deploy a website there, or create a Docker container and deploy a Docker container, or deploy a database. So it's up to you how you're going to use it. You're not restricted to like any use case, and but you actually manage like a lot. So you will be responsible for updating your operating system, like making it secure, even though AWS will offer you the VPC, like will provide you secure perimeter for your instance, secure, like, will secure network and so on and so forth, but you're still going to be responsible for network within your EC2. Like, for example, if you expose your EC2 to, anyone, so anyone can access it. So, and then if anyone can access it, there's possibility someone can hack into it. So that will be your responsibility. So, and think about EC2 is like building block for many AWS services. So most of AWS services will be running on EC2. So, like, for example, if you think about EKS is Elastic Kubernetes Service. So there will be cluster of EC2 machines running together, and then with Kubernetes software on top of it. So moving right, we have PaaS, so is a platform as a service, and one example is Elastic Beamstack. So basically it's a service it's like one step further to like making your, to make the service less manageable. So meaning, so you don't need to provision a lot of things. In platform as a service, for example, you can deploy WordPress website. They will offer you like load balancers. They will manage some part of your database and backend and front end, but still there is, so it will have like a layer for you that the AWS is going to manage, but you still have like an overhead of managing your hardware, for example, for like when you need to scale, like let's say traffic increases. So you need to think about how to add extra computation power. So, and then you basically need to manage it, right? So then we moving right, there is a CAS. So it's a container as a service, means container as a service is, I'm not sure if you guys are familiar with Docker. So Docker is a big thing right now, like allows you to deploy many different software on the fly using notion of containers. And containers is like micro VMs, then you can run on your, for example, EC2 instance, and you can have like many of them. So what Kubernetes does is basically allows you to deploy and manage your containers in a production fashion. So it will take care of a lot of networking. It will take care of a lot of scaling, redundancy, make your application resilient. So yeah, I will take care a lot, but you still need to manage that EKS cluster. So there is a lot of still like Kubernetes is quite complex tool. So you still need to do a lot of like work to make sure everything running smoothly. And then far right, we have serverless. So serverless, like for example, BAS or FAS, meaning backend as a service, or function as a service. So backend as a service considered like, for example, DynamoDB. Function as a service is Lambda, and serverless containers is Fargate. So these are completely managed services by AWS. So you don't need to think about anything, updating, security, patching, nothing. So everything will be take care by AWS. So you just, for example, with Dynamo, you just download, like, create your tables, download your data, and make it, that Amazon will make it globally available and, like, and highly scalable. Similarly, with Lambda, you have your logic, like as if, for example, Python code, you can deploy it, you can connect it to a gateway endpoint, and right away, for example, you can, call your logic from a browser, and like, let's assume that logic will, do something, and you can get results right away. So you don't need to think about anything like scaling your services and so forth. So there is underlying hardware. So it doesn't mean there is no servers there, right? There is underlying hardware there, but you just don't need to do anything with it. Serverless architecture allows developers to focus on software design and code rather than infrastructure. Serverless technologies feature automatic scaling, built-in high availability, and pay for use. So if you see here, so like you can think about serverless price-wise. I would say if you compare, for example, Lambda function that's running the same amount of time that with EC2 instance probably would be considerably cheaper than Lambda, but you will see there is some use cases when Lambda function can be significantly cheaper than EC2. So, but think about still going left, you will like services will become less expensive, and going right will be kind of, if you pay for computation, if you like break down like how much you're going to pay for the computation time, the going right will be more expensive because AWS manages a lot of it, and they of course will have some extra costs associated with this. So serverless pros and cons. High scalable and reliable without managing any servers. Competitive pricing. So like another benefits of serverless infrastructure is, so you need to do less code because you don't need to, for example, think about networking, and lots of will be abstracted. So you just need to focus on your business logic. So as I mentioned, there are many other serverless services that AWS offer. For example, it's DynamoDB. It's a NoSQL, highly available global database. Then step functions. Step functions is, you can think about if you have multiple Lambda functions and you want to create a logic to to orchestrate your Lambda functions in really elaborate logic. So you can use step functions to do that. And then there is a serverless platform such as serverless application model, which is short for SAM, or there is a cross cloud framework which called serverless. A similar idea. It allows you to manage your Lambda functions in production kind of way, in production environment. For example, if you have, let's say, your application or your, platform or whatever you build in a cloud uses hundreds of Lambda functions, this framework allows you to manage them quite nicely and version control them, test them, and deploy them without actually using UI. Just if you have 1,000 functions that you need to edit, can you imagine how much time you're going to spend to go to your AWS UI and then edit each of those Lambda function and redeploy them, test them, make sure everything's fine, and again verify everything works, and then deploy them again. So those frameworks quite useful when you deploy more like production, when you deploy like your like complex applications, mostly event-driven application in production. Lambda. So Lambda was introduced around 2014 and shortly became really popular, one of the most popular AWS services. It's fully serverless, no maintenance needed. You don't need to think about like hardware, operating system, network layer. So as I mentioned, AWS will take care of everything. Then also important thing, it also will like have to scale automatically on the fly, depends on the number of requests your Lambda is receiving. It will scale up and down automatically. So again, huge thing for certain applications that have like, for example, like seasonality, or if traffic significantly changes during like certain hours. So you don't need to think about infrastructure, like scaling your infrastructure at all. AWS will take care of it. Yeah, and price based on usage. So basically there's two components in Lambda for what you pay, is the how long the round how long Lambda was executing your code, and then size of size of memory, how much memory you're allocating. And you guys gonna see there is a direct correlation between amount of memory and computation power that you can allocate to a Lambda function. Yeah, it's of course has implicit high availability, less code as mentioned, as for any serverless services. So you don't need to, as I guess said, like lots of things is abstracted and take care by AWS. So Lambda supports many languages like Java, Go, PowerShell, C#, Python, Ruby. Surprisingly, Node.js and Python are the fastest languages when you deploy like Lambdas. So in real time, like in real life, so probably Java will be significantly, or C# will be significantly faster than Python, but because every Lambda function will be deployed in a container, and deploying containers for Java will require more time. Therefore, Lambdas running using Java languages will be significantly slower. Pricing. So as I mentioned before, pricing depends on two things. The first one is memory size and function execution time. But those two, as I mentioned, they are related to each other. So you need to, for example, keep in mind that memory size impacts the processing power allocated. So what it means, so if you double your memory size, you're automatically increasing your computation power. You're basically doubling your CPU. So meaning if you double your memory and you double your CPU, you can decrease your function execution time. So you're paying for two things. You're paying for execution time, plus you're paying for memory. So, and some smart people came up with this solution. So you can check it. It's open source. So basically it allows you to run your Lambda function and kind of fine tune it to kind of find this like perfect equilibrium of function of execution time and execution cost. So as you can see here, for example, with 128 megabyte of memory, Lambda was running close to like 2.5 seconds. And then, was slowly increasing the memory. Therefore, we're increasing the computation power. And at some point, the cost will go up, of course, but we can find this perfect sweet spot where the cost is not increasing significantly, but execution time drops significantly. So as you can see here, for example, with 1 GB of RAM, the Lambda is running just a fraction of a second, and we're paying basically for the same, paying the same cost. So yeah, going back to what I mentioned, EC2 pricing and Lambda pricing example. As I mentioned, Lambda pricing depends on two factors: maximum memory allocation and execution time. Depending on the task, Lambda can be significantly cost effective compared to EC2. For example, if we have infrequent task, say something that needs to run for every 5 minutes for about 10 milliseconds and need 512 megabytes of memory, Lambda pricing would roughly work out to slightly 1 cent per month. Where for running EC2 instance for exactly the same, let's say 1 month, will cost you about $9. However, if you single Lambda function constantly receiving requests and never stopping for a month, that would cost you $30. And but think about EC2. You still have this overhead cost, you need to plan your capacity, you need to think about your after scaling, load balancer, and so on. So even with $9, right, and plus thinking about this extra cost, Lambda can be still cheaper. But again, this is just a good example about when you think about what to use, what services to use in Lambda. So what services, either Lambda or EC2, you need to think about your specific use case. The service is a piece of hardware, typically a virtual machine that runs on one more physical piece of hardware. Sorry, I didn't get the question. So I just don't see the chat, so I need to open it. Yeah, server is basically what was answered. So server is basically you can think it can be a virtual server, or it can be so technically, if you think about server, actually it should be bare metal server, and then VM, it will be a piece of a small piece of that hardware that allocated for this VM. And one server can have multiple VMs. There will be hypervisor that will basically manage the hardware and allocate those resources between VMs. But think about server as super powerful computer that can be split into multiple pieces, into multiple smaller, less powerful pieces where you can install software OS and run your software. That's basically how EC2 works. So Lambda limitations. So no session affinity, meaning you don't have like direct control over like starting and shutting down containers. So VMs Lambda might send to Lambda might send two subsequent request coming from the same user to the same container or to different containers. So meaning you like how Lambda scales and scales up and down, you don't have control. That will be managed. So you cannot say, hey, any new request sent to a new container, or any, like repeated requests from this user sent to only this container. So you cannot control this logic. It's controlled by AWS, and they probably find the best algorithm to do that. No deterministic latency. So Lambda is not optimized. So Lambda does not optimize for minimize latency. It's optimized for like high throughput applications. So which basically like limit Lambda to, like, you, for example, won't be able to use Lambda if you want to use like a machine learning model that uses like high frequency trading, for example, where like you need to get result in milliseconds, or like fraud detection, like where like milliseconds plays a big role. So because latency is a big things in Lambda, so you probably don't want to use Lambdas in these cases. Yeah, another really big thing is even though like it's getting really like less important, is cold start is time when incoming requests need to wait for a new Lambda micro VM, or like you can call it a container or micro VM, to be processed or to be created. Before it was a really like kind of big problem. If you attach your Lambda to VPC to, for example, access to make it access resources within your VPC network, and you invoke Lambdas, it will take quite significant time to create those containers within the VPC. So recently, this problem was resolved, and even when you attach Lambda to VPC, containers getting like created quite fast. But you need to always remember about this when you design your applications. In addition to number of requests, right? You need to understand what the volume of like your application or your logic is going to receive. You need to think about the limit of how long Lambda is going to run, how long your like business logic is going to be running within that Lambda container. So you maximum have like 15 minutes. So that's why for longer task, if you want to have like a similar idea to run something serverlessly, like don't think about hardware and software, operating systems and so on. So you can use like Fargate. Fargate, basically you package your business logic into like a Docker container, you deploy it in a Fargate, and that thing can run like longer than like 15 minutes, can run hours, so can run like basically forever. So, and another thing, you don't have control over processing power. So you have like, you cannot like just double, let's say, I have, for example, for your Lambda function, 512 megabytes is enough. And you say, but I want to get more CPU for my Lambda function, because memory is like, it's not like memory intensive, but I need like, it's more computational intensive. So you don't have this option to control CPU. So you can only control CPU by increasing memory size. And 1,792 megabytes is equal roughly to 1 virtual CPU. Yeah, so okay, there's a question. Can Lambda write to system disk such as event logs, etc.? Yeah, Lambda is using CloudWatch to write logs. But you can have like, so Lambda is stateless, so there is no persistent storage. So like, that's what you need to remember when you write Lambda. You don't write any stateful applications because there is no persistent layer to store your data. All the storage layers ephemeral. So you're gonna have a temporary folder that you can use to store your data. For example, if you have like 2 Lambda function and you want to pass the data from one Lambda function to another, you can do that. But like storing data, no. All the logs will be sent to CloudWatch. So then you can, and it will have a dedicated storage in AWS, and you can, go on and check the logs that Lambda produce. Hope I answer your question.
Sam, thanks for answering that question. So for the Lambda, that sounds very similar to Azure functions. Like I have a question, like if I have a software, like the code I developed based on Lambda, how easy for me to move that to different platforms such as functions? Like how easy to move the code?
Yeah,
that like
you like if you want to move your code from one cloud provider to another, you mean?
Yeah.
Yeah, it will be super easy, right? So like the logic will stay the same, within your like Lambda code will stay the same. It's just how you the logic probably will be different, how that Lambda is going to be called, because
right
to invoke, right? So
yeah,
because AWS, you have to have event and context. Cloud function, I think you just need to have one variable to there. So you just send your payload, but the idea will be similar. You're basically invoking your Lambda by sending a payload, and then the payload getting processed, and then the output can be sent to another services. So we can, yeah. So I don't think so. It will be super difficult. I would say it will be quite easy. Yeah.
Okay, cool. Thanks.
No problem. A good question. When to use Lambda? So there are like use cases when you want to use Lambda. So if you think about like maximizing your throughput, something that you like, you have like a huge amount of requests, you're serving the dynamic content, database access, automatic emails, replies, chatbots, you probably would want to use the Lambda. API-driven microservices, event-driven infrastructure, internal integration. Yes, you probably would need to would want to use Lambda. When not to use Lambda, so when you think about like high latency systems, as I said, like high frequency trading, probably don't want to use Lambda. Long running tasks, as we know, Lambda has hard cap on 15 minutes. So again, don't run Lambda. Like use Fargate or use like something else, EC2, or Kubernetes services, EKS or something. High memory requirements. So yeah, 10 GB for RAM and 10 GB for like that. Temporary storage is maximum. So large data sets, therefore, Lambda won't be able to process large data sets. So Lambda is not designed to like big data. So don't try to, deploy your big data pipelines using Lambda. That probably gonna there are like other tools you can use like Kinesis, Kafka, like streaming solutions like pops up and and so on. And then when you need high computation, so of course, yeah, if it's not designed for big data, therefore it's not going to have lots of compute power. So maximum what you can get is 6. At this moment is 6 CPU, virtual CPU, and there is no GPU. So if you need to, for example, if you think about to use Lambda to create like deep learning models, so no, use EC2, or there is specific like hardware that AWS offer you, like can offer you to build your deep learning models. So on how Lambda works under the hood, if you guys familiar with containers, right? Docker, for example, it's a similar idea. So it uses this framework that AWS created, and actually you can read about it here. And I think this is actually was open source. So similar idea like Docker, you have your like kernel base, like like Linux kernel that you can utilize to deploy to use that kernel to deploy micro VMs or containers that is going to use that kernel as the core, and on top of it you can install, for example, different operating systems, different like runtimes, network layer, and so on and so forth. So similarly, like like Lambda will do exactly the same. Has two types on invocation. So yeah, so most of the use cases when you're going to see Lambda is used is event-driven applications. So what I mean by event-driven is like basically you can create and design your logic by like thinking about like like if something happened, I can invoke a Lambda function, and Lambda function will do something. And probably one of the like examples that easy to understand. Let's say you have a website, and someone like you open this website to users, for example, to upload their images, right? And then you want to like, and people can upload any type of like any size of image, right? It can be super large raw pictures, right? But for example, feature image, you want to use like a thumbnail, like a smaller image size. So you can like use Lambda to when people upload the image, you can invoke Lambda, resize the image, and upload it to another bucket that will be used to render a page, like to render that feature image. So that's kind of will be like event-driven, small application that Lambda can handle. So like person upload the large image, Lambda get triggered, resize the image, compress the image, send it to another bucket, and then from there it will be picked by like website and rendered for user. Also, you can use Lambda in to pull data from services like DynamoDB, Kinesis, MQ, MSK, or SQS. So if you're not familiar with any of this, so this is basically just message queue. This is a managed streaming Kafka. So this is like a managed Kafka offering that AWS offers. And SQS is a simple queue service. So all of these are like related to streaming applications. And with Dynamo, for example, how you can do the streaming is let's say new records comes into your Dynamo database. You can create a Dynamo streaming and then send that data to Lambda. And then Lambda, for example, can do some operation on the data and send it to, for example, you receive some data. Lambda will process the data on the fly, for example, calculate the cost and send it to another Dynamo table. Yes, Dynamo is AWS offering. Yeah, and no, there is no other services that no others like GCP will have Bigtable, similar idea to Dynamo. But I think Dynamo is, you can get Dynamo DB. I think it's either HBase or Cassandra. So if you think about, yeah, Dynamo is Cassandra, I think. So if you think about like if you want to deploy open source version of Dynamo, you think about Cassandra. So similar idea, like masterless infrastructure. So yeah. So like how you can trigger your Lambda, there are like multiple triggers you can use, and like we will see it in UI. But so you can like use HTTP request to know. Then you can use API gateways. You can like, for example, invoke from like when like from events, for example. This like three most common ways of invoking Lambda, right? This API. API will be considered as synchronous invocation, because gateway will always wait for Lambda to return a response. When you create your Lambda infrastructure, you need to think how like all of this services that going to use Lambda is actually work, because API gateway has a 29 minutes seconds timeout, which means if your Lambda doesn't return any response to gateway within 28 seconds, it will time out, which can be like really important when you design it. So if like you would need to think about how to, maybe if your Lambda is taking longer, maybe you need to split it to multiple Lambdas and then maybe allocate more resources. So you need to always think about those limitations. Lambda extensions. So in addition to like pre-built extension, like some connectors already within AWS, Lambda also offers extensions, and those, like there are like so many of them. Some like it's just an examples of them, right? Like you can, for example, you can use Splunk if you have any connection to cybersecurity. You probably know what Splunk is, and then you can use this Splunk extensions to like, for example, monitor your Lambda environments, and create real-time metrics, and see where like bottlenecks is happening within your Lambda. But remember, when you use extension, it is going to use your Lambda resources such as CPU and memory. And of course, the good option, like the good offering that AWS provides, is you can create your own extensions. So you let's say there is a third-party service or tool you want to use with Lambda, you can easily create an extension and use it. Yeah, change in data capture, probably it depends, right? If something like Dynamo, so you can stream the data directly to a Lambda function, but let's say if you have like MySQL or something like that, and it depends how busy your database, right? Because for CDC, I would say I wouldn't use Lambda per se, because we know there is hard cap on 15 minutes. But I would use something, if you think about serverless, I would use something like AMR serverless cluster. and run like maybe Spark and then send it to like a Kafka topic. Is it possible to map events to execute a specific Lambda function? So you're not sure you'll like question map events to execute a specific Lambda function. You like each Lambda function is going to have like Lambda handler that you can distinguish your Lambda. So you're not sure about event. The trigger event you will define like from like where to like you want to trigger your Lambda. But yeah, you can do this, I guess. But yeah. You can, yeah, Lambda packaging. So you can like, package your logic in a zip archive and, a Docker container. So you have like two options. If with all like you can create, an application and with all your dependencies, zip it. If it's less than 50 megabytes, you can, download it as is into Lambda. If it's more than like 50 megabytes, you need to use S3 buckets. But if your application is more than like 250 megabytes, you can package your application as a Docker container and send it to Elastic container registry. And then you can invoke your container as Lambda. Just remember when you, use containers, AWS is not going to take care of updating your OS, patching it, doing any maintenance. It will be up to you. But with zip files, they can actually, actually patch and apply security patching for it. No extensions will be still running in serverless environment. Because basically think about Lambda, think about Lambda as a glue. So you can basically glue together lots of external and internal services within AWS. So it's not a big data processing, but you can glue together certain components. For example, you can invoke AMR cluster, invoke the Spark job, do a big data processing, and then send you think about you can create the event-driven pipelines using Lambda. Lambda layers. So Lambda by default will come with only a limited number of dependencies, like Python libraries. If we talk about Python runtime, so therefore, if your code needs extra packages, extra libraries, you would need to create a layer, and it's pretty simple. You basically download libraries. For example, pandas or whatever, you zip them, you save that zip file in a S3 bucket, and then you can use that zip file in the when you create a Lambda, you can then say that location, the point to location where you save the zip file, and say this is a layer. And then you can attach that layer to your Lambda function, and Lambda function will be able to download the zip file to every container, unpack it, and properly use the dependencies libraries that you provide. So storage, as I mentioned, you will have an access to temporary storage. Again, you're writing your Lambda is stateless. It should assume there is no affinity to underlying computing infrastructure. Any persisting state should be stored in S3 or DynamoDB or Elastic file storage. Yeah, you receive 500 megabytes of free, no persistent disk storage in its own temporary directory, which you can increase to 10 GB if needed. So yeah, you can another good use case to use this temporary storage is you can use it as a caching layer. So for example, like let's say you have a Lambda that does something, and then there is an output. Like there is some like Lambda returns something to like a user. So you can like, instead of every time rerun this function, you can store this output into a temporary file. And next time when this container running this Lambda function will receive requests, you can say, hey, instead of like, rerun the function, just send back the results that already, been pre-computed. Which will like reduce the cost, which can reduce cost quite significantly. Step functions. Yeah, step functions I mentioned before. So think about like, if you're familiar with Airflow, sometimes like some companies right now, they're trying to replace Airflow with step functions if they just use AWS services. So yeah, it's a great orchestration solution that AWS offer. In addition to manage Airflow, you can just use step functions where you can create create like a crazy logic using Lambda functions running in a parallel, invoking, like branching, or like lots of cool stuff. But in addition to work with Lambda, you can also trigger other AWS services as well. You can see there is a video here just explaining you like it's really nicely explain you how to like create a small projects running a few Lambda function and orchestrate them with step functions. And there is a Git repository for this project. If you're interested, you can do like a homework to play with Lambdas and step functions. Cold starts, as I mentioned before, cold starts was a kind of significant problem for a little while. Especially people who needed, latency for their applications, like, high latency. So when like cold start happens is when platform, like Lambda platform, needs to spin up a new runtime environment. So creating a new container, loading all the dependencies for the runtime, and this time will take this process will take some time before the actual Lambda can accept any requests. So yeah, when will cold start mostly occurs is when you change the code, when function has been not invoked for roughly for an hour. When previous environment containers has been expired due to age, roughly 6 hours, when all containers are in use and Lambda needs to scale out. So again, right, let's say you have a Lambda functions that been invoked once an hour or a little bit more than an hour. So meaning every time that Lambda will gonna have a cold start. And yeah, and even though if it's quite, if container is still quite, active, it will be redeployed after 6 hours. And of course, if your number of traffic or number of requests just, like skyrocketed, like then there's going to be time for Lambda to create an extra containers to, accommodate that increase in traffic. But should you actually care about cold start? Probably not much. As you can see, this it's been taken for a recent study. So Python cold start is only like 250 milliseconds. Java 11 is 480 milliseconds. Java 8 is like the longest one. So as I mentioned before, most application apps are invoked frequently enough, and if you Lambda get invoked 10 times per second, then you would get about like 0.1% of cold starts. However, your Lambda gets invoked once an hour, then you would get about like 100% of cold starts. Yeah, like Rust and Go. I'm not sure about like Go is close to like a Java. I'm not sure about Rust. Rust is not super efficient. Probably Go is like more efficient, but they did these tests, and apparently still Python is like for Lambdas, Python and Node.js is the fastest compared to any other languages that like runtimes that Lambda offers. So how you can improve cold starts if it's like critical? You can reduce the number of dependencies if it's possible, or you can increase memory size. You can actually like there is a new things that been recently offered. It's provision concurrency, meaning there is going to be a number of like warm containers. So meaning you're going to have a number of containers on standby always, which definitely going to reduce the cold start. But you would need to remember, you would need to pay for these containers. So you basically, those containers will be always running. So therefore you're going to pay for them, like, for as long as you're going to keep this provision concurrency. Yeah, and or use different language. As I mentioned, Python and Node.js seems to be the fastest one when you use Lambda. How you can design your Lambda. So there are like two kind of schools of thought, designing Lambda. You can think about like a monolithic way, or like a single purpose Lambda. So there is no like right and wrong. It depends like again about your business requirements, like execution time, allocation resources. So, but it's up to you how you can design it. Either it can be one big Lambda with many functions within it, or it can be multiple Lambda functions. Then you can chain up together and run basic. Yeah, let's go and just deploy just the simple Lambda function. So when you're logging into AWS environment, you can just search Lambda, and then you can click this star thing, and you can going to create a shortcut here, so you can then easy access your Lambda. To create function, you just need to create this button. You're gonna have a few options when you create a Lambda function. So you can create Lambda from scratch, use a blueprint. So blueprint is like a templated functions that already available, so you can use them, just modify them, and for example, get S3 S3 object and so on, using Lex and so on. Or you can use a container images, which is if you have like a pre-built container that you want to use in Lambda. So we're going to use just a simple from scratch option. I guess, yeah, I think you can. I never thought about it, but I'm pretty sure you probably can template your Lambda functions. Yeah. You probably can use something like serverless or those like SAM frameworks to do that. So here we just give a name, like selecting a runtime. Yeah, we can create a new Lambda with basic Lambda permissions, advanced settings. So advanced settings, we here, for example, enable code signing. Is there like most of these are security features? So code signing is like, you can sign your code, and if like, like somebody changes your code, and if it's not signed, it's not going to be deployed. Enable URL. So there is a new things that been recently introduced. So you can have like you can attach an endpoint, HTTPS endpoint to your Lambda function. And then, for example, you can have like a different authentication methods associated with this. In our case, we're just gonna use none. There is another option, right? Cross-origin resource sharing. So you can also enable this security feature to make sure that, to permit access to resources that are, for example, if you have a script that's running from a different browser and trying to call this endpoint, you can basically restrict it and enable tags. So tags are similar, like all the services within AWS you can tag, and it's mostly for billing control. So for example, you can say, hey, this Lambda is going to be tagged with data engineering team or data science team. So later on, you can see, like in the billing and like filter only, like services that are associated with a specific team. And enable VPC is your account is going to have a default VPC. So and then basically virtual private cloud. It's kind of like this environment that is kind of logged down to your, like it's kind of perimeter of like network perimeter that you're going to be allocated to you, and then you can basically enable Lambda to use VPC. For example, why to use it is, think about if you have, let's say you have EC2 instance, and you have EC2 instance, and in EC2 instance you have an application, for example, a Docker container that has an endpoint, and then you, like, for security reasons, you want only certain IP to access this endpoint, but you need to your Lambda to access that endpoint and, like, I don't know, invoke something or get the information for something, basically to submit an API request. So because Lambda is, think about, Lambda is serverless, right? There is like, can be 1,000 containers invoked. So like, and each container, it's impossible to allocate specific IP, right? You don't know, you're not going to know like what IP to you can whitelist to, in order to, like, to security groups to allow Lambda to access your endpoint. So what you can do, you can put your Lambda into VPC. Then you can have like NAT gateway attached to it. And then you can have through a NAT gateway, you can assign a specific IP address. So in that way, kind of all the Lambda requests will be going through a NAT gateway to specific IP, and that IP you can whitelist. So that's one of the options why you would need to enable VPC. So we're not going to do it for now. So this is basically the UI for Lambda. So this is like a canvas here where you can see Lambda, you can see layers, and layers are, just think about layers are dependencies, for example, or like libraries that you want to attach or add to your Lambda. Currently there is no layers attached. You can use like triggers and destinations. You can, for example, there is a list of triggers here, right? So one is called like associated with AWS services, and then you have also third-party triggers that are built using EventBridge. So there is like lots of them. You can like use Shopify, I don't know, like MongoDB, I don't know, like Zendesk, Datadog. So like a lot of them, right? In addition to provided by like AWS services. Then we have a destination. So meaning to, like, let's say we received a request, we received the payload, we did something with it, and then we can send that request to like downstream, right? So we can use simple notification service. It's basically like a push notifications that you can send to your phone or your browser. Then you can use SQS. So it's a simple queue service. Similarly, if you have so similarly like Kafka, or PubSub, but this one works like one-to-one, where like with Kafka, you can be like one-to-many, so you can, like one producer can produce one topic and many consumers can consume from that topic. With SQS, it's only one-to-one. Then you have you can basically send the request to another Lambda function to invoke another function, kind of chain them up. And then EventBridge. So, and EventBridge is just the you can create basically extra extra connectors using EventBridge with the third-party tools. Okay. Now we have this top menu. So code is where you're where you're going to write your logic. Then test. So test tab is basically similar to if I click here on the test tab, I will land to in configuration option. So before you run your test, you need to configure your payload. And for example, here we're just using hello world payload that we're going to send to Lambda. But you can have you can mimic whatever you want, like S3, for example, delete, put object, and so on. And this is basically how the generic S3 put payload looks like. Monitoring. Someone asked about logs. So yeah, you're gonna have a matrix here about your Lambda. How often getting invokes? If there is any error messages? If you need to increase your computation resources. So basically, you can do a lot of you can derive a lot of analytics from here. Then this is the view logs. Where you're going to view logs is the CloudWatch. I'm going to introduce it to you. So basically, it's where we, like going like to check logs and troubleshoot if something going on like with your Lambda. Configuration. So the basic general configuration is where you like edit your memory, like default 128, ephemeral storage 512. So, and then timeout is 3 seconds. So like basically what timeout means, if your Lambda is not finishing within three seconds, it's going to timeout. So it makes for, like a lots of, so basically for the purpose to save your money, because if you put it to 1 minute, and you have like a wrong logic or something is not working within your code, Lambda is going to keep running for 1 minute, and you're going to be charged for the time of for that like basic execution time, even though it's a fail after 1 minute. So that's why, like when you test your function, it's good to have it like small, and then if you need to increase it, you can increase it. You can increase timeout, right? Or if you want to your Lambda run faster, you just need to allocate more memory to it. So triggers is similar, exactly the same like we've seen here. Permission. So every AWS service by default is gonna have this role of least privilege. So meaning each service is kind of gonna be isolated from other services. So that's, like it's rule of thumb. So if you want your service to talk any other services, you need to provide proper rules, assign proper rules to that service to talk any other services, either like EC2 or S3 or AMR and so on and so forth. Destinations we covered already. Function URL. So yeah, it's similar. This is the HTTP endpoint that I mentioned before. So it's just like redundant here and there. You can just invoke it, and you should see that like return return message from here, right? So hello from Lambda. So yeah, so for example, environment variables, it's really nice feature to have. For example, let's assume your Lambda need to talk to like access a database, right? Or something, like this is the way how you can, kind of create your environmental variables and then call them from your Lambda function and kind of not expose those, like secrets within your Lambda code. Tags I mentioned before, just for tagging purposes, mostly used for billing, right? So when you can then like go and search and filter for specific tag and see how much it it costs for a specific tag for months and so on. VPC, this is concurrency. So yeah, as I mentioned, like, right, you can allocate some lambdas to be on standby, and yeah, so to avoid the cold starts. Code signing or database proxies. Yeah, database proxies is a nice feature to have. Let's say your Lambda by logic need to talk to database, and let's say your Lambda gets too many requests, and then those requests is going to be sent to database directly, which can cause the database overload. So you can attach like database proxy to mitigate like those spikes, and they will like kind of help you to limit to not limit to manage those spikes. File system state machines. So state machines is the associated with step functions. So those kind of like, when you orchestrate your Lambdas, you would need to create the state machines. So let's just play a little bit with Lambda. Just to, for example, let's just, like do like a simple thing. From date, time, for example, and then we can print. Let's do this time stamp equal date time, for example, and then turn it into string. Here. Once. And then let's do seconds too. Our, yeah. Like this. And then let's print it. Print. Yeah, the to pass data to Lambda, you just need to pass this event. So that's like we're going to see. So like you can see the Lambda when you create your Lambda function, you have to have two type of arguments. One is event, one is context. Event is the payload you receive like when you invoke your Lambda, and context is basically information like metadata information about a Lambda, like how long, the execution time, the computation usage, so the memory usage, and so on. You can use it to like derive some statistics, but it's actually provided in the logs as well. But the main most important part is event. So you can just like just invoke Lambda like to like as I said to send to destination here and to select another Lambda function here, and then just like find your Lambda here, and then that event is going to be sent to another Lambda. So yeah, now if we just test it, okay, you always need to deploy your Lambda. After any change, you click deploy and then you test. Maybe just wait a bit. Yeah, not sure. I guess yeah, I need to create the a test event for now. Like we're okay with this. Test. Save. So that's basically the event we sent to Lambda to invoke, but this what we just print out is just today timestamp. But let's go back and test event test. We can do something. So and then save. And then here we can, like just do another print statement, do event one, deploy, test. So we should see the the payload that we just the value of the payload that we just pushed to Lambda. Another way you can deploy Lambda, if you're not familiar with, there is a service called, it's free to use within your AWS, it's called Cloud Shell. So similar to like, I guess GCP has cloud. I think it's called Cloud Shell 2, probably, I don't remember, but so similar idea. You have like, this is micro VM that runs within your environment, within your account. It has, like the AWS API installed, so you can talk to any services within your account. It's quite handy, if you can like list your like S3 buckets, for example, copy file to S3 bucket, copy file to your local computers. So yeah, it's quite handy tool, but also you can use it to deploy Lambda, for example. You can use AWS Lambda. Invoke, and then you need to provide one function name flag, and then name of your Lambda function. Then you need to do CLI and I think it should be format role. Yeah, it should be in base 64. I think this one is to serialize your payload, and then you provide payload which should be valuable JSON format always, because if you provide not valuable format, what's going to happen? So Lambda is going to complain. So I draw this simple diagram, basically how Lambda, will work step by step. So you send the request to Lambda service, and then first few steps, it checks if you have if it has the Lambda you're trying to invoke has all necessary permissions. For example, in this case, I need to access S3 services. Then it will verify the payload, the JSON payload you're trying to submit as event to Lambda to make sure it has a proper format. So if the payload has a proper format, you will see 200 response. If you have some problems with it, it will gonna complain, So if you see 200 response, it's not necessarily your Lambda is, was successfully, completed. It just means that the payload is correct. So sometimes it could be confusing. You still get 200, but you're still getting a, some library missing or something like that, right? And then basically when everything is just passed, the Lambda service is going to deploy a container or micro VM with the runtime that you previously selected. That's why we need to always have the correct payload, and then we can have key again, right? Because we used key as a payload before for the test, and we can use cloud data as the value. And then we always need to provide the output file, so output.txt, for example. Payload, yeah. So yeah, it was successful. And then if we cat yeah, we can see the return message. And if we go back to if we go back to and check the CloudWatch, let's see. Under log groups, you need to select your Lambda, and then basically this should be the last one, I believe. Yeah, you will see the message that we just submitted via Cloud Shell. Yeah. Okay. Yeah, let's just create this quick kind of like pipeline. So let's assume we have this S3 bucket. Let's kind of create this like event-driven small, like, pipeline, let's say. Let's call it pipeline. So we have a S3 bucket. So then we're going to land a file in this S3 bucket. We're going to create metadata from this file. Basically, like, we're going to create a pandas data frame. We're going to apply describe function just to describe the data frame. Then what we're going to do next, we're going to get the data and save it as a file, and we're going to call this file metadata, and then we're going to store this metadata in the S3 bucket. So in order to do that, we would need to use pandas library, but we know that like lambdas doesn't come with pandas. So you can actually check what libraries are available for you using this package. So let's import set, and then you can create a for loop for working set, and then you basically need to print package, and then plus equal plus package. So we're gonna print the package name and then the package version. So let's test it. Yeah, I forgot to deploy it. Test it. Package. I think I misspelled something. Project. Yeah, I think it's project name. Project name. Yeah, so as you can see, it's only a handful of number, like only, like as you can see, there's like a few libraries available for us when with default runtime. So like most likely, most of them gonna have Boto3. If you're not familiar with Boto3 or Boto Core, is this library that is created by AWS. This is referring to Python, of course, Python runtimes. So I'm not sure if other runtimes have Boto, but Python definitely has. So this is library which allows you to talk to any most of the AWS services. You can see it has really nice manuals, so you can like create a S3 object to talk to S3 buckets. For example, you can delete file, upload file, you can deploy MR clusters, you can do lots of things with the Boto3. But you see there is no pandas. So by the way, the package that I used is part of this setup tools package. So like if you're interested, but let me show you how you can add the pandas into this function. So remember I was telling you about the layers. So I already have a layer created. So I basically have this pandas library, store a zip file. I upload it to S3 bucket, and then I edit it as a layer. So now I can go to functions and add layer. So I can add layer, and then I can select the custom layer and pandas and select a version. So there is another option to add layers. There is a publicly available GitHub repository that has pre-built layers from Lambda for different runtimes with the different packages. You can find any packages you need basically. And it's easy to deploy. You just go to that repository, grab the Amazon resource number, and then you place this resource number here. So you don't need to, and then you don't need to worry about creating your layers. So those layers, they maintain them, they update them, they do such a great job to providing a new packages or a new library. So you probably going to find most of the packages you would need. But if you don't find it, then you will create your own layer and upload it to S3 bucket and deploy in this way. So now I'm adding this layer to Lambda function. Now the pandas is going to be available for me. Can import so now let's create the trigger. Before we create a trigger. Let's create this because we need to use S3 trigger. We select S3 trigger, then we select the bucket. I have a bucket somewhere here, demo lambda. Then we need to use prefix. So basically where which folder, even though S3 is object storage, there is still a notion of folders, even though there is no folders, but we still need to can kind of mimic them. So we put input here. So it's the folder kind of where we're going to put our file. And then you can also use suffix. So basically you can provide the extensions for your file. So Lambda will not only look into a prefix into folder, but also going to look for file extensions. For example, you can do .jpeg or .csv or kind of make it more robust. But we're not going to use it in our case. Also, you need to acknowledge that you like when you process the data, the output of your Lambda function is not going to be the same folder as an input. Because if you do like the same folder, you're basically going to create infinite loops. So like the Lambda going to process the file, then going to output the same folder, then the Lambda is going to be invoked again, and then again and again and again. So we're going to have this, and it's going to cost lots of money. So pay attention when you create your, when you design your Lambda function, make sure that input and output folders are different. I guess okay, let's use input. Maybe I used somewhere already. Input 2. Yeah, I need to go to S3. Then Lambda. Create folder. Folder. Yeah, not sure. Let's, I think something is wrong with my bucket. Let's create a new bucket. Bucket. Create a bucket. 2. 2. 8. Create folder. Okay. Substage. Okay. We create a trigger. So now we can like, yeah, let's just be like, let's do it. Now we can quickly invoke it and see the payload print event. Yeah, I'm not sure about if it has to be in the same region, because buckets usually they still like they kind of have this global notion, but they still to be associated with region. I would say try to use the same region. You could have like some problems with different regions. Yeah, with some services. I'm not sure about like Lambda. I know some services like really picky about region because do not share the network resources between regions. But I'm not sure about Lambda. Lambda should be like a global, so maybe it shouldn't matter. Yeah, I'm not sure. Try it. So it is. So let's just drop a file. So I'm gonna just have just a simple file here. So this is the cannot find the file. Yeah, this is the file I want to upload. So it's just simple file. So very cool to know. S3 event can't trigger a Lambda in different regions. So good to know. Thank you. So this is the file I'm going to upload, just a simple comma separated file, like yeah, nothing special, but where's the Lambda demo folder, input, drop file, upload, then go to login demo. So maybe wait a bit. Yeah, sometimes it takes time to generate the logs. Yeah, let's just continue with the logic. So if we go back to test and just select the create a new event and then select S3 put. So this is like this the event that we supposed to get. So we're gonna get, like a bunch of information about the event, the timestamp, the region. We're going to use the bucket, then name to get the bucket name, and then we're going to use object to get the file name that we're uploading. So let's go back to our function. So the first thing we're going to create this bucket. We're going to get bucket, and so it will be event, and then we're going to take records, right? Records. So records, then 0. Then we're going to get bucket. Then we're going to get file key. Going to get file key. So file key will be similar to, I think instead of a bucket, we're gonna have object, and then key. And then we're going to get like path, and we need to get the file name, right? We get to meet the file name in our bucket. So for file name, we're going to import OS, and then we're going to use this OS path split method, and then we're going to pass the key here. So basically getting the file name, and then we can print them, but let's just, and then like now we need to think about, we need to read the file. For example, we have like file name now, and we can create a data frame with PD read CSV, because we're using CSV file, and then Yeah, but before that, we need to load this file to let's load this file to temporary folder in our Lambda, like to use that ephemeral storage layer. Like let's do import Boto3, and then let's create the Boto client, Boto3 client, Boto3 dot client, and then S3. We need to, yeah, S3 client. So now we can S3 download file. File. We need to provide bucket. Bucket. And then we need to provide the file file key, I believe. And then from where we're going to download it, it's going to be temp folder, and plus we're going to name it file name. Now we can read the data from the temporary folder, temp, and then basically plus file name. And let's say we want to create this metadata from this file. We're going to use df, right, and then we're going to save it to CSV, and then let's put it back to temp folder, temp, and call it CSV. So now we can use again S3 Boto connection and upload file that we from the temp folder, this file. And then we need to provide bucket name where we're uploading, and then the key, kind of the output key. Remember, we need to provide a different output, not the input. Like we were going to call it output / because it's just the key. Like we don't need to create a folder. Folder will be created on the fly, and we call it meta. And then, for example, plus file name. Okay, let's deploy it and try to test it. It should be about it. Let's go back to G. Close. File. Close. Nine. So this is the payload. Something doesn't like something. Okay. And records 0. Oh yeah, I missed the. I guess I missed the. Yeah, I missed this one. Close. we upload the file. Upload. Yeah, so now we're getting 403 error, meaning 403, when you see 403 in your Lambda, that means that your Lambda doesn't have the permission to access certain resources. So in our case, it doesn't have access to S3. So to change the permission, you need to click permissions, then on the role name, and it's gonna open IAM management. And then here you would need to add permission and attach new policy. And then you need to search for S3. And like you can attach, this one, like in our case, we're just gonna give it full access to S3, but you can, you will see this gonna have just a JSON format, and you can have like free documentation how to, for example, make it more granular and have access to only one bucket, for example, for security reasons. In our case, we're just gonna give it full access to S3 service. Let's again upload the file. I need to click close and then upload file. Upload. Source. Yeah. Yeah, it's created. Yeah, so I'm not sure the CloudWatch is lagging. So, but as you can see, if I go back to the where's the buckets? If I go back to buckets, right? So I have input, I put the file here, I have the output folder been created, and there is our metadata file, CSV. Now we can go here. Nice feature of S3 that you can actually, if the file is small, you can query data using SQL. You just predefine what the type of the data, CSV, comma separated, not compressed, and then you can write your SQL here, run it, and you're gonna get your data back here. So we're getting the basically statistics of on our data frame, right? That we on our file, sorry. So you can see count, unique tops, frequency, and so on. Yeah, a little bit sorry guys, it took a little bit longer, but this was basically a demo for Lambda for today, and you can just, yeah, I think we covered basically like everything here. So any questions? So I'm taking it as a no. Thank you everyone for joining today's session. I hope you guys find it helpful.